So today we're going to talk about functions, and we're going to talk about functions as rules and machines, and in real life, what would a function represent? Also, we're going to see how in mathematics functions are represented in equations, arrow diagrams, tables in ordered pairs, and as graphs. And we're also going to talk about relations. One can think of functions as a rule, where if you are given an input, you can expect a certain output. In math, we say a function is a relation in which each member of the domain corresponds to exactly one member of the range. And we'll talk about domain and range as we go through this lesson. So let's think in the world, just what behaves as a function. So remember, a function is you provide an input and you expect one certain output. So let's think of like a typewriter. If on my left hand I hit the middle row with my pinky, okay, I could expect an output of an A. So each key has one output. Also, cars behave as functions. In many things on your car, you want to behave as a function. If you press on the brakes, you don't want to think, well, my car might slow down or my windshield wipers might go off. No, you want to provide an input and you want your car to provide one output. Also, think of a vending machine. If you go up to a vending machine and you want Cheetos and it's at C3, well, if you put your money in and provide the input, which was pushing C3, you want your Cheetos. You don't want to think, well, I'll push C3 and I might end up with Cheetos, or I might get Funyuns or pretzels. Okay, that would not be a function. So you want the vending machine to behave as a function. So let's think of some things that do not behave as functions. Gaming relies on this idea of things not behaving as functions because things aren't predictable. And so that's the whole idea of gaming, is you might win and you might not win. Like a roulette wheel. If you think about your input being you spin the roulette wheel, well, it could end up on a lot of different outputs. Also, when you play the slot machine, if your input is you pull down the bar on the slot machine, well, you're not guaranteed one output. There could be many different outputs. Also, when you roll a pair of dice, if the input is you're going to roll the dice, then you could get many different types of output. In mathematics, we look at this and we say, okay, say that we provide some inputs. We provide number 1, 0, 4, and 10. And our teacher says, well, your answer, if the input is 1, the answer is 3. If the input is 0, the answer is 0. If the input is 4, the answer is 12. If the input is 10, the answer is 30. Can you guess what the rule is for this situation on the table A? So if you guess that you multiply the input to get the output, that would be right. Let's look at table B. You provide the inputs 2, 3, 5, and 10. When you guessed 10, your teacher said, well, the output's 5. If you guessed 3, the teacher said the output's 7. If you guessed 5, the teacher said the output's 11. And if you guessed 10, the teacher said the output's 21. So can you guess what the rule is for this function? If you decided that it was you multiply the input by 2 and then add 1, that would be correct. So let's look at this one. This is a little different. You provide the inputs 2, 4, 7, and 1. When you guessed 2, the teacher said the output was 0. When you guessed 4, the teacher said the output's 0. When you guessed 7, the teacher said the output's 1. When you guessed 21, The teacher said the output is 1. So can you guess the rule for this one? So this one's a little different. It said when the input is even, the output's going to be 0. And if the input is odd, the output's going to be 1. So sometimes we depict functions as machines. We provide an input to go into the machine, and then something happens in the machine, and then the machine spits out an output. So here, this is the square. We're going to square the input machine. So we input the number 6, and then inside the machine 6 is squared, and so the output is 36. So let's look at another machine. So we're going to input 4, and then the rule is to add 3. So that's going to happen in the machine. So then we have 4 plus 3, and we get an output of 7. So then if we want to make a table, we can provide different inputs, and as it goes through the machine, we add a 3 to each input, and we get outputs. So we can also write this information as an equation. We can write f of x is equal to x plus 3. And note that our input is x and our output is f of x. This is written in function notation. If we were going to show the inputs and outputs that we previously had on the other slide, we would write this as such, where we have the function at 0 is equal to 0 plus 3, so it's equal to 3, and so on. The inputs that we supply is our domain. The domain is the set of all possible inputs. And the range is the outputs. It's the set of all possible outputs. So we are going to determine domain and range for some examples later on. Let's look at this machine. It says, is the input-output machine a function machine? For any natural number, input x, the machine outputs a number that's less than x. So think about that for a second and determine if you think that is a function or not. Okay, this would not be an example of a function, because if we put in the number 10, then the output has to be a number less than 10. So the output could be 9, could be 8, 7, 6. It could be anything less than 10. So we provide a specific input, 10, but it gives us, it could give us different outputs. So one way that we represent functions is with arrow diagrams. Arrow diagrams show a correspondence between inputs and outputs. Now let's look at these examples that were given. In the first example, we see that each input is designated to one output. That would be an example of a function. In the second one, we notice that 0, 1, and 2 are each designated to a certain output, but the number 3, it could be designated to 4 or to 10. So that would make it not a function, because if we gave the input 3, someone could say 4, other people could say 10, so there's not one output for the input of 3. So let's look at these other examples. Which of these figures represent functions? If there is a function, can you recognize the domain and the range? So give yourself a minute to look at those and see if you can determine the functions and the ones that are not a function. The first one is not a function because number 1 is designated to both 2 and 4. So that rules it out to not be a function. Now the second one, the middle one here, it's a little bit tricky, but it's not considered a function either because for a function to exist, each input has to be designated to an output. And here you have the letter B, it hasn't been designated to an output. So that rules it out as being a function. The last one is a function, and the domain, the inputs are X, Y, Z, and the range is A, B, and C. Notice that D hasn't been assigned to any input, so we would not consider that a part of our range. Let's look at a couple of more. We have a couple of relations here, and decide if you think those are functions or not functions. You can pause the video if you need to. And then if it is a function, determine the domain and range. First one, it is a function. The domain is John, Mike, Joan, and Sue. The range, the outputs, are Brown, Smith, and Doe. The second one is also a function. The domain is 0, 1, 2, and 3, and the range is 1, 4, 7, and 10. Now let's look as functions as ordered pairs and tables. Given the situation where you have a lawn service and they have a certain fee schedule for their customers, we can express this in a table or in an ordered pair. Note that in the table, the input is the number of acres to be mowed, and the output is the price. And that's also represented in the ordered pair. The input is the X value, the number of acres, and the output is the Y value, the price that it takes to mow that number of acres. Let's look at some examples of ordered pairs. So look at these and determine if you think that this represents a function or if it does not represent a function. If it does represent a function, determine its domain and range. So if we look at letter A, this is not a function because we notice that the number 1 has two different outputs. It has 2 and 3. So you can't have the same input with two different outputs. So let's look at letter B. And this is a function, and the domain is 1, 2, 3, and 4, and the range is 2, 3, 4, and 5. Let's look at a couple of more ordered pairs. So here, look at C and D and determine if you think this is a function or not a function. So letter C, that is a function. The domain is 1, 2, 3, and 4. And notice the range is just 0 and 4. 0 is the output when the input is 1, 2, or 3, but we don't write it 3 times. We just write it once. For the second one, they're saying A is a natural number, and then that's the input, and B, the output, is 2 times A. So the domain is the natural numbers, and the range is all the even numbers, because if we took a number and divided it and multiplied it by 2, it would just be our even numbers.